Hi, I'm Pradeep Kadiyala, Senior Solution Architect for Financial Service Cloud. In this video, I'll be showing a demo on modernizing the zMainframe applications using secure DevOps on IBM Cloud environment. I'll be using IBM Cloud services and Z developer tools. First, we will see how Adam, who is a cloud admin, can deploy an isolated secure and compliant environment through automation. Adam opens IBM Cloud Console and selects the toolchain service from navigation menu. Adam will create a new toolchain to deploy infrastructure as code for the IBM Cloud for Financial Services. Adam will then choose the deployment region and already defined resource groups and gives a name to the toolchain. Adam chooses VSI pattern to deploy Wazi instance. Adam creates a new repository to maintain the infrastructure as code. Adam generates a new IBM Cloud API key to provision resources. Once all the configurations are entered and submitted by Adam, IBM toolchain delivery pipeline is created. Adam will then go to the code and customizes the resources based on the requirements. Adam will provide resource configurations for key management, resource groups, VPCs, network access controls, subnets, x86 VSIs, and VSIs with Wazi custom image. After Adam commits the code, the pipeline gets triggered. A compliance scan is run to validate the infrastructure. All the resources are provisioned on IBM Cloud. Adam checks the Wazi VSI instances, VPCs, subnets, network access controls, security groups, and finally, VPN gateway to access the resources securely. Adam has now successfully deployed IBM Cloud Framework, which is secure and compliant. Deb, who is a developer, requests Adam to provide a developer environment so that she can perform development and testing using secure DevOps. Adam will provide dev spaces for Deb by creating an OpenShift cluster on the VPC, which was already provisioned in IBM Cloud Framework. Adam opens the OpenShift cluster and installs the Wazi dev spaces operator from the Operator Hub catalog. Adam creates a license for the installed operator before use. Adam then creates a Chi cluster where Deb can use it to create her own dev workspace. Adam updates the configuration with appropriate registry and timeouts to allow time to pull the images from the registry and create the workspace. A Wazi dev space URL is generated where Adam can log in and create a dev space for Deb with appropriate IAM access policies. Now Deb with right IAM access policies will log into the dev spaces using URL provided by Adam. Deb will create a new workspace with git URL of an application she is intended to work on. A new workspace is provisioned on dev space cluster where Deb can now use Visual Studio IDE workspace to code and develop COBOL or any other applications. After dev environment gets created, Deb would like to create DevOps on the COBOL application she is working on, so that the commits made in the dev workspaces will trigger the build and deployments onto Wazi VSI instance. Deb creates a new toolchain deployment pipeline for her ZOS application using the predefined CI template with secure DevSecOps practices. Deb chooses the deployment region and resource group and gives a name to the toolchain. Deb provides the Git repository details for ZOS application. Deb provides secrets manager instance to store the application sensitive data. Deb then provides the details of the Wazi VSI instance using a cloud API key and SSH keys to access the resources securely. Once all the configurations are entered and submitted by Deb, IBM toolchain deployment pipeline is created. Deb runs the deployment pipeline. The pipeline will run with unit tests, builds the artifacts, and deploys to the Wazi dev VSI instance. With this, Deb can now develop code on dev workspaces and deploy the application using secure DevSecOps. Deb now wants to expose the functionality of COBOL applications using z/OS Connect APIs. Let us look at a demo on how to expose APIs using our dev workspace environment.
In this video, we're going to show how new features of the IBM Z and Cloud Modernization stack can really allow you to increase your digital engagement. We're going to take the example of an environment that already has a chatbot that allows a customer to ask it questions such as, "What are my car policy details?" The chatbot calls a back-end application and is able to respond with the car policy details. But if the user asks questions such as, "What are my account details?" or "What is my profile?" the chatbot does not have access to that information. Therefore, it cannot respond adequately, and instead responds with more details about the car policy. So we want to change that to improve our digital engagement. Our first protocol is with a solution architect, Simon, who's going to use ADDI to get a visual view of the entire application end to end to try and find which application would provide the information for this application. Once Simon is happy that this is correct, he can now create an issue in GitLab or another issue tracking system to provide the developer Deb with the information she needs to create a new API. In this case, Simon has created an issue in GitLab, and he's going to attach the call graph gathered from ADDI to that issue and key information that Deb is going to need to develop the new API for this application. Now the issue is updated, we can move on to Deb to start creating the work that she needs to do to create this new API. Once Deb gets the ticket and she understands what is required of her, the first thing she's going to do is to create a new private development area for her to work on. This will be a copy of the code that she can use, isolated from anyone else. She now has access to code, tools, and the sandbox where she can test her changes in complete isolation from any of the other developers' work. When she's ready to start work, she just logs into her code-ready workspace and begins working. Once the configuration steps to provision her environment are complete, all she has to do is open the environment to begin working. She's now got direct access to the code through a browser-based IDE. If Deb wants to confirm the work that Simon has already done, not only can she look through the code that is available and already been mapped into the IDE, but she can look at the code within IBM Wazi Analyze to understand the flow of control between the different programs, the interfaces that they use, and exactly what API or interface she needs to expose. Because a z/OS Connect API designer image was already deployed as part of her project, there's a link available right in the IDE that she can use to go straight to the API developer. The chatbot development team has already provided Deb with the API that she needs to fill in. So the first step is to import that industry standard Open API specification. Once she's done that, the tooling will visually show her the layout of the new API. She can see all of the paths, the components, the schemas, and start to get a feel of the API that she needs to build. This layout and design is very similar with other IBM tooling, such as API Connect. So Deb feels right at home in this interface, and working directly through the browser means she didn't have to configure anything on her local machine in order to get this experience. It's consistent across the organization. When she's ready, Deb can now import the copybook directly into the designer and create a new z/OS asset. In this case, it's going to be a Kix COM area program, but other options are available. She'll enter in the program name, the language of the program, its code page, and also a connection to a Kix system. Notice that many of the fields are already filled in. This is pointing to the Kix region running in the Wazi sandbox that she provisioned earlier. This means that when she's ready to test, she'll be able to test it against that deployed and provisioned environment, rather than having to deploy it and configure new connections herself. She's now imported the COM area, or the digital interface, to the program that she needs to export. Deb can quickly check that this is exactly what she was expecting. And when she's ready, she can just replicate that for both the request and the response structure. Now the ZOS Connect designer understands both the API specification that has been provided by the business as well as the ZOS asset interface that these will need to map to. The final step is to give it a name so she can understand what this ZOS asset does in case it can be reused as part of other APIs. Once the ZOS asset has been created inside the ZOS Connect designer, it's now time to map fields from the Open API specification to the COBOL interface. In most cases, this can be done just by a one-to-one mapping between the field in the COBOL API and a field in the Open API specification. In those cases, things can be easily set just by dragging and dropping from one form to the other. However, if something more complex is necessary, for example, concatenating certain fields together or applying a function over the information provided, that can also be done inside the ZOS Connect design as well. In this case, we need to hard-code a variable into the request structure and also map an input parameter from the URI into the COBOL interface. And when Deb is finished with the API, she'll be able to test it immediately. Because it's all been deployed in the background, there's no need to deploy or move this to ZOS manually. Deb can immediately test the API directly from the IDE just by clicking the Test button. Selecting the Test button opens up a small form-based IDE where Deb will be able to test the API. Here, she's not just testing the API against a stub or a mock, she's testing it against a real version of her Kix application running in the ZOS sandbox that she provisioned earlier. So she's certain that it's going into Kix and into her COBOL application and returning real data. This means that when she's ready, she knows this is the right application and that things have been tested reasonably well. So she's called her API and she can see the customer data that has been returned. Deb's API has now been built successfully and is ready to be distributed to the rest of the organization. While Deb has been building the API, all of the new API projects and all of its assets have automatically been added into her IDE. This means when she's ready, all she needs to do is stage these changes, add a commit message, and then push her changes back to the repository. Now that her changes have been pushed back to the Git repository, it can now be built, tested, and deployed as part of a pipeline. So we can now start to test the entire end-to-end application. Now we'll go back to our chatbot. Now if we ask for account details, we can clearly see that we get the information back about the user's account details. So from end to end, we've shown how the new capabilities within the IBM Modernization stack allow us to build new digital engagement into existing applications running on the IBM Z platform.